Earth. I'm sorry.
Well, but you said that it's like the sphere is the gaps. It's like sphere of the gaps. It's like God of the gaps. It's really
No, it's
interesting.
easily measurable over small distances. It's been done. I have many observations that I could present. Again, I didn't walk in. I was just kind of chilling, listening in here. The only reason I got involved is that a good, someone that I know personally that has utmost integrity, his character is being attacked in favor of someone who's perhaps one of the most vile human beings on the internet.
Can I speak on that too, guys, please, real quick?
I don't want to have a debate.
I have many more, like, listen, I have many friends on both sides, and this is one thing I know. I want to stick it for some of my people that I'm like, hey, no, don't do that. At the same time, honey, you don't know what these people are saying and doing when you're not around. And I've started to learn that, you know what? I will just say, I don't believe this and leave it at that. I want to stick up for other people on here. Let them stick up for themselves. Okay, honey, just support you. I'm just giving you advice. I'm not telling you what to do. I'm just saying, because I've learned that as soon as I stick up for somebody, I'm like, no, their integrity, no. And then I'm like, oh, damn, they said that? You know what? Never mind. So I just stick to my own shit. You know what I mean? But I get you wouldn't defend it for them. Guys, I wouldn't defend people on here. Not to that degree.
Fair enough. But I would be, okay. I'll just say advice noted, Stace. Thank you.
Let's be hard.
Hey, C-Line, do you happen to have the type of experience necessary that this man doesn't have?
I have many measurements that others have made that I can present.
Okay.
And
well, he's providing his testimony, and you characterized it as if like maybe you did have the experience that he didn't have. That's why I was asking.
No, but I wouldn't claim that.
But if you just have like hearsay from other people, I understand.
No, I wouldn't claim that my personal experience is relevant. Like, I wouldn't claim that because I've worked as a mathematician, that somehow gives me special knowledge into the shape of the Earth. That's only true insofar as I'm able to understand things like inertial navigation and the principles thereof and things of that nature and general technical knowledge. But I mean, if you're saying your construction experience and local measurements of level is relevant to the shape of the Earth, it's fallacious.
Well, I mean, would you say that perhaps he has more, in the field experience with this topic than, you would qualify for?
Not as far as I can hear. Like I said, I think that my opinion on the subject is that it seems to me that, I mean, there's this beam that Globers are like, oh,
we can let it go. We can let it go.
It's okay. All right, we can let it go. Fair enough, Griggs.
I can just make a little poll or something in the chat. It'll be fun.
Oh, sure, go for it.
What's inertial navigation, Captain?
It is the way that all heading calculations are done on aircraft and most navigation systems function. You have basically an inertial system is a gyro-stabilized platform. So you have 3 gyroscopes in the roll, pitch, and yaw axes. And then you have 3 accelerometers. And that system is used to calculate heading and work out your position independent of GPS. There's 2 reasons for that. The first one is that GPS doesn't provide heading. The second, which I know, Jen, the pitch data. I know, Jen. Don't please.
Well, yeah, well then that means you should shut up then, because what you're bringing out is rubbish.
I don't, Jen, buddy. I was just trying to answer his question. Can I just please answer his question?
You're describing.
I don't want to get into a debate with you on pitch data, please.
We're describing a positional system so far that's relative only to itself. And okay, so how does that inertial navigation, Captain?
How does it what? I'm sorry? Your volume's a little low for me.
When we go to warp speed, Captain, how do we do the inertial navigation? Just explaining it. Go ahead. You described the system.
Yeah. So basically, there's actually a funny meme that's kind of relevant to this, which is it's from an Air Force training video, but it's called the missile. The missile knows where it is at all times, and it's kind of funny because the way it's described is like overly technical, but basically, you figure out where your initial starting position was, and then do you know what dead reckoning is?
So you're using visual item as well now?
No, you're not.
Dead reckoning is a sighting of a landform from the air that you're able to like identify and get a general relative position. Am I wrong there? That's from the ground up.
That's a specific type of dead reckoning.
That's like for fucking flying, isn't it?
It's a specific type of dead reckoning. What I'm referring to is like basically if you're going from point A to point B, you maintain a
heading.
you maintain a heading from point A to point B, and then
Do
you
you
can
not
use
need a
dead
visual
reckoning to
ID
get
of the
from point A
thing?
to point B. You
So
integrate your
you're gonna
position over time.
you're gonna skip seeing a river. You're gonna skip seeing the ocean. That's not a thing. You don't even need to do that because you
No,
just
not
didn't
with
even.
inertial navigation, because basically you
That's not
you
dead
know where
reckoning.
you were starting, and then you integrate forward your position. So do you know what
Yeah, well, let me tell you this. Like, so if you're just talking about a mathematical plot, basically you have a X, Y, Z with sensor data. Like, there's no dead reckoning because there's no description of anything to fuck around you.
maybe dead reckoning's not quite the right way to
What
put
are
it.
you dead reckoning? Like, you know what I mean? It's like, so I know that guy. I dead reckoned his fucking face, right? Like, there's no positional data. You're like, oh yeah, well the XYZ
No,
yaw
but
was fucking
there
here,
is
so then
positional
therefore,
data. There's
yeah,
your
you don't.
past position.
What is your other data in which, because that's like a snapshot, let's say, like from that snapshot we can then take and index that information and then figure out like where's east, where's fucking west, am I going this fucking direction, am I going down, like that's dead.
So
That's
here's
what,
a cool little representation of it.
great. Captain, just tell me about inertial navigation. That's all I
That's what
need
I'm trying to
right
tell
now.
you. But the best way to explain it is with the basic principle of dead reckoning, and that. But rather than using an optical reference, you just use your reference of your past position, and then you basically integrate forward the positional updates that have been recorded based on the changes in the pitch, roll, and yaw axis and the accelerometers.
Well, that's just not that's like if you had that on a paper airplane, you know, like I fly the paper airplane and I have little sensors on it that show like, oh yeah, this is how fast it was going. Oh yeah, and it did like a little turn. Oh, and the wind caught it, and then it like fucking crashed like this. You know what I mean? If we had all that positional data and I can plot it in a Cartesian like environment or something like that,
Mhm.
little 3D thing. How the fuck is that telling me about where I am? Like
Well,
that is not
that's what I'm
descriptive of
saying.
anything else other than it's self-referential. Like I said, so all you have done so far is describe like a positional system, but you've
Yeah, that's
told me
basically all
nothing
it is.
about how
Man.
that's navigating. So get to the navigation, Captain.
Yeah, the navigation piece is that as you make updates to your position, you know where your past. You have a time series or like a series of your past positions. But like when it comes to the actual like plotting forward of a course, you don't use an inertial system for that. The inertial system is to like, in some sense, record your position relative to like a pre-mapped course on the globe. Like for an airplane, right? You make a determination of initial heading, which relies on Earth rotation. That's the major way that it's done. And there's 7 ways to calculate heading. You could use a magnet, of course, but the issue with magnets, compasses, is that they are subject to a lot of interference. So they're not really appropriate for use in commercial navigation applications at scale anymore. So what you do is you determine your initial heading, and you can see this yourself if you ever, well, you have to be in the cockpit, but every single one of the, I don't know, bays, like, where the jetway comes down and you walk onto the plane, will have the coordinates like down to that position in the airport.
Okay, so
So
you're just
when you roll
navigating.
up, hold on, when you roll up,
It's just
you
differential
determine your
position.
initial heading. You determine your
Is it,
initial heading.
then
You
you're just
determine
talking
your
about
position.
is it just a differential from your start position to using
That's the way
coordinate
that's the way the inertial system
three?
works.
Yeah.
But you
Okay.
also
Thanks.
use
You described
GPS.
it. So you're doing no actual like navigation,
No,
right?
you are doing navigation. That's the
No,
thing.
you're taking a start point. That's already like that's kind of baked into the cake. And once you have an accurate start point, then whatever you do from there,
Right, but the
if
point
it's
is
measured by sensors,
you can use an inertial
you
system,
take your pitch,
purely inertial.
and you take that data from
Uh-huh.
there, and then you're going to map that to like a vector that moves in like a 3D space, but you're only starting from whatever your origin point is, which you had no point in doing any of the geodetics, any of the measurements to what that place was.
Yeah,
You
you have
just
no,
take
you
that
do,
data because
because
it already is in existence.
so you pre-chart a course, And then the inertial navigation system measures your position relative to that course. But it can work. I mean, you can use an inertial system to figure out how to get from point A to point
It's
B.
just relative or
without-
differential positioning based on an origin point of established.
Yeah, but
quality,
you can
right?
get, my point is you can get to
Captain,
point B
right?
and you
Wouldn't
can
that
work
be a
out
better
your
way to say it, Captain, with your inertial navigation?
to say what?
What I said. You're
It's
taking me
you're-
through a lot of pitch and roll and yaw.
Yeah.
You know, in the conversation to try to just like not explain the term. I'm just asking what is the term? And thank you. We've arrived. I think at least I understand what I think. you
Well, I'm
mean.
not sure that you quite do, because like
Oh.
missiles, for example, before GPS, missiles don't rely on GPS to know where they are. So they have a pre-mapped course on a great circle route on the datum, but once the missile takes off, how does it know where it is relative to that pre-mapped course? That's where inertial navigation comes in.
What kind of missiles are you talking about? Like do you think
Every
I
single
fuck
missile you can
around-
think of.
You fuck around with missiles, dude? Who here is shooting missiles off? Anybody?
Uh,
Just hobby
every
missilist?
you can
Any
you can
fucking
easily
people
look
here?
at the
Does anybody-
documents. And,
So such as to say that you have no fucking idea how they work, and then I might have a much more like of a specific idea about how some of these systems
do
work.
do you think you know more than me about how they work?
But
Do you want to go
are you
through
thinking
the
that
military
that's
doc?
actually going to like help you prove what you do? Like you're trying to describe your fucking job to me, right? If you have to go
No,
into
my
missiles,
job
which is
isn't
something you
related
don't.
to.
If missiles are not something that you fucking do, then how is it describing your fucking job?
I'm not. I
hate
never
to be
was.
too
You
Jersey
asked
this
me.
early.
You
I
asked
should
me
take
what
a break.
inertial
This is
navigation
getting
is, bro.
my blood pressure up.
You asked me what inertial navigation is. I'm just trying to give you the best explanation that I can give you in layman's terms for what you asked. Assuming your question was in good faith, that's it. I'm not an inertial navigation expert. I know how Kalman filters work. I could, if you give me a couple years, I could write. I mean, maybe 6 months. I could write you a inertial navigation program from scratch. But I haven't done it before. But I understand how it works. I know experts that work with these systems day in and day out, that I could refer you to. They hang out here sometimes. That have built,
I
take apart and
apologize.
rebuild.
I thought you were saying that you do this. That's why I was addressing you as captain.
No,
Sir.
I'm not a navigator.
Okay. And
But I know
inertial
I know-
navigation would have very, very little to do with like I guess the other types of navigation that we talk about here, right?
No, it would have a ton to do with it, because it's really similar to a lot of the same principles.
It's like
Ye-
well, because you're saying that the navigation, inertial navigation, is happening because the Earth is turning. You did utter that statement, which I think triggered me to.
Oh no, it relies on the fact that the Earth, it needs to compensate for rotation and curvature to
Right.
maintain a fixed inertial reference. If you do not account for those effects, you'd end up like hundreds and hundreds of miles, if not thousands of miles off your course.
No, they have built-in altimeters, which is referencing surface level.
Yeah, no, you can't get heading from an altimeter.
The navigation system you're talking about has altimeters built in.
No, the inertial navigation system is based on accelerometers and gyroscopes. There's a separate system that has an altimeter. With these systems all interface together in a complex way in modern aviation, and there's double redundancy on every system. But like you have GPS, which determines your position very precisely. Like you can get down to like centimeter accuracy on GPS, but GPS doesn't determine heading, and there needs to be double redundancy.
What's
So
the difference if we have a 7-meter line and we put a compass on each end of it? We're going to get a lot of skew here between these two different compasses at 7 meters distance.
No, probably not.
We have some though.
Yeah, there's going to be.
Okay.
I mean, it may not be measurable. You need an extremely accurate compass to measure it, but most likely you would have declination. Yeah. Huh?
Is there not like a digital compass of some sort, like a more?
Yeah. Magnometer. Let me
Magnetometer.
find that. Yeah, magnetometer or whatever the fuck it's called. I'm saying it wrong, but
Compasses only work horizontally.
yeah, that's a silly statement. What do you mean by that? Compasses only work horizontally. We're not talking about compasses really anyway, but do you
Well,
mean that compasses wouldn't work on the globe? Is that the
I mean,
meme you're going for?
like, I guess what I'm trying to establish is that, like, let's say if we had a compass like at the front of the plane, a compass at the back of the plane, can we
Yeah.
not like determine that there's going to be some kind of differential between these two things, and then that is enough to deduce a heading?
So if yes, you could, but the reason that, and we do have compasses. So if you're in a cockpit, there is a final backup system for heading, which is a compass. The reason that compasses are not used as the determiner of heading and inertial systems are used instead is that inertial systems are less subject to interference and are more accurate. That's why ships have been using gyro compassing for, since like, I don't know, the 1920s, the 1930s is when gyro compassing really became popular. Because you have declination and then you have other sources of magnetic interference. And in an airplane where you have all of these different electronic devices operating, and then in a modern environment where there's electromagnetic signals as well, all of that interfaces together and creates issues for compassing. So that's why we use inertial navigation. And if you really want to learn more about it, like I'm planning on giving.
Okay, I'd like to one now.
All right, go for it, Jen. Let's hear about the pitch data.
Thank you very much. Ladies and gentlemen, everything this guy's been telling you is relying on Earth rotating. As Earth doesn't rotate, and Albert Einstein couldn't prove that the Earth was rotating, he'd come to the conclusion that no optical experiment could be conducted to discover Earth's rotation. At the University of Kyoto, Japan in 1922, making that statement, and we ourselves, the flat earthers, we're not detecting Earth's rotation. The Coriolis doesn't exist. Aeroplanes are not landing on a rotating globe ball, right? And snipers are not taking into consideration the Earth's rotation when they make their record shots at 4.4 miles away. Earth is not Earth is stationary. So the equipment known as a magnetic gyroscope that he's talking about isn't showing that the Earth is moving.
Okay. All right, Jen.
So
let's.
right.
Do you want to see some? If I show you manuals, Jen, where you just say that they're fake?
The manuals are there, fraudulent manuals. They're there to dissuade you from the globe.
So there's no point in having a conversation. What if I showed you data?
There's no point. There's no point when I know what I know. Yeah, there's no point when I know the Earth is stationary. Your book is fraudulent.
I know, buddy.
You know.
I know.
I'm glad you know. I know. I'm glad you know, buddy. I'm glad you know, but
Jen, I know that
Jen,
there's no amount of evidence that will convince you of anything.
Nonsense.
So I just wish you the best, Jen. I don't see. I was having a good conversation with
Earth is
Stax.
stationary, ladies and gentlemen.
It was moderately good.
I mean, here's the thing, man. I'm not an expert in inertial nav, but if you really want to learn more about it, I know people that are. So I'm planning on having like seminars on the topic, not to like advertise outside of the server, but I would like people to attend them regardless on what their views are on the shape of the Earth or whatever. So because I find it a really interesting
I just don't like, even though I think it's fascinating science, like, because basically with what you're saying, you could replicate like things like simulators, and because like a flight is a linear item, like it moves from in a line or wherever, even if it's a curvy line.
Yeah,
it's something that plots, like it has a speed, like actions happen to navigate to like the airplane in such a way to make the curvy lines happen. To those actions we can simulate. I've spoken to people that have like designed them from like scratch, and like managed like these systems for like 20-30 years, and they're retired, like on pension from like this type of shit. So like, and that guy, believe me, he wanted to tell me about microchips and shit that he was using like in his setup that he had built for the prototypes and stuff, the early stuff. Pretty fascinating stuff, man. But it's like, it's separate. It's separate from the planar sort of mapping, all that stuff.
Yeah.
To me, it's a separate science.
Yeah, I mean, gyroscopes are kind of like magic to me, honestly. Like, and the fact that before GPS, like, and you could dispute whether this is a real number or not, but like, Charles, like Flat Earth Charles, Flat Earth Math Charles has his
Don't
dad
mention
used
him.
to work on the
Sheesh.
well, his dad used to work on the ICBM program, and one of the things he was saying was that the missiles were accurate to within 100 meters over like 8,000 nautical miles, only using inertial reference.
Like, is that true? Like,
Yeah, that's
I
true.
don't. I know. I mean, about his dad being that. Like, I just consider everything he says to possibly just not be true.
I don't know, man. I mean, I don't know Charles as well as I know like Bacon, for example, but like he hasn't given me any reason to doubt his honesty on anything. So, but I mean, obviously, I'm biased as someone that comes from like the globe side, right? But yeah,
I'm saying that somebody to prove their case might be able to just make the case that, like, because like they might know loosely about something, then it's easy to claim like, oh yeah, and yeah, my uncle was he was in the CIA military intelligence program. I didn't really know about that, but
yeah.
like
No, I
you
hear
can
what
just
you're
throw that cred out there, and people are like, oh yeah, really, yeah, the guy's like, he's like really in it. It's funny. I wonder.
Yeah, but
Like
even when
somebody else could make some
when you're
kind of case.
referring to a nautical mile, my mate, you're referring to an elevation angle.
Oh, come
Latitude.
on. Don't start with this elevation angles to Polaris, Nathan Oakley crap. I don't have time for that. Let's just try to have a conversation here. I am not going to engage on Nathan Oakley scripts. I don't have time for that crap.
A latitude measurement's got nothing to do with Nathan Oakley. Neither has a nautical mile.
Elevation, if you're talking about anything regarding a flat baseline and elevation angles to Polaris, that is Nathan Oakley. I'm sorry.
Well, that's how it's measured. That's how Earth is measured.
No, it's not. You should learn from people that actually do this stuff and not random shitheads from the UK that insult people on the internet. I'm sorry if that's where you're getting there.
And you're the one trying to protect people from calling people, and now you're calling people.
Well,
you just insulted him by trying to call him out as some kind of insulter. You realize you just did that?
No, I'm not talking about One Deck. I have no idea who One Deck is, but Nathan Oakley is a horrible human being.
Well, you just insulted him while saying that he's this insulting guy, but you just insulted him. You just did
I mean,
calling the kettle black.
I call it like it is, man. If you see me,
but you just did the thing that you said he does. I'm just saying, you just basically.
So if I say that someone is insulting someone, aggressively muting people and just generally being a horrible human being, is that me insulting them, or is that me saying a true statement?
Well, it's not what you said before, but I don't really care to nitpick on it. Those were not the words you said.
Yeah. Okay. Well, fair enough. But
anyway, it's okay. Don't worry. Don't worry about it. The gentleman obviously doesn't want to talk about latitude measurements or elevation angle measurements. He's got an issue with that, obviously. So I'm just pointing out that that's proof of a flat Earth, and you don't want to talk about that. So we'll end the conversation.
Yeah, fair enough. I'll disengage. Yeah, I would like to have more interesting conversations than that. So.
Interesting morning. Even though I will say I kind of agree, because I could even say Nathan's an ass, and I don't like to insult people. But in reality, I get it. It is a double speak.
Maybe I kind of get what you're saying, but like.
Oh yeah, I totally get it too. It's why it's so funny, because it's true. And then second, I was talking to you earlier about construction, and Killian was talking to you and everything. And I was just looking up the Amazon building because I couldn't remember how big it is. I think the biggest one is 166 million square feet or something like that. I forget what it is. You have to look it up. It's like 6 miles. Okay, they're saying. So you think that wouldn't have anything to do with if someone was doing construction and done with that, they wouldn't have to worry about anything, or no?
Yeah, if you were working on a project of that scale, you would have to make some adjustments, definitely. I mean, over 6 miles, there's a deviation of level from horizontal, measurably. It's not a huge deviation, admittedly, but there's a measurable deviation.
I just want to make sure we're on the same page of that when it comes to construction work. When somebody mentions I do construction, I mean, a lot of people deal with this stuff and they don't understand what it takes to lay foundations and everything and what you're going to do to measure and all that. So I'm just saying, Just
Yeah,
because someone says construction, don't throw it out because a lot of these construction workers know how to deal with things, right? And tools and level and all that. So just I'm saying, when you hear somebody
Okay.
say construction, they probably know a hell of a lot more than you think, though.
Okay, that's fair. And you know, I have a lot of respect for people in the trades. So I mean, so yeah.
Oh yeah, me too. Actually, that's a hard job.
You know, I think that and one of the things I always say too is like there's a lot of the meme, I mean, like, you know, people are always saying like, oh well, flat earthers are just like living in their mom's basement, they don't have jobs, blah blah. It seems to me like most of the flat earthers that I talk to work in the trades. Like at least here on Earthaway.
Right. There's a lot of people work in the trade or have worked in the trade. You know, they've dealt with it one time in their life, so they're like, "Well, that made me think." Or, you know, a lot of us have jobs. In fact, I was working too damn hard not too long ago before I broke my knee. Can you please not ever let me work again, please? Can I stay at home in my mama's basement? I actually would love that right now,
Yeah.
but I can't. Okay,
Yeah.
you gotta take care of me.
But you know, like when it comes to stuff, you know, it's like, you know, like obviously we disagree, but like, you know, like I've, you know, like I've never had an issue with you, for example. Like I have no reason to like ad hom or insult you or anything. Like the only reason I do that with Oakley is because the way that he acts. But we don't have to talk about the meta anymore. Like,
Yeah, treat people how you want to be treated, and you kind of get that same respect back. I mean,
Yeah.
that's the best that you can do, and you may not always get it, but you can just try to.
yeah, that's true. That's fair.
And the old thing of like two wrongs don't make a right. So taking the higher road is a level of integrity that is challenging, but has infinite rewards.
Fair enough, Gio. I appreciate that feedback. Obviously, you know that I don't always do that. So
Do any of us always take the high road?
I would like to also add, sorry to cut you off
You're
there.
good.
I'd like to also add that Nathan Oakley can be abrasive when necessary, when it's due, but generally he's a nice fellow, a man of impeccable integrity and honor, and delivers the flat earth truth, much to the distaste of the Globers. And I love that. I love that the Globers are distasteful with Nathan Oakley's precision. He's abrasive when he needs to be. I'm the same. Okay? And that pitch data, which you didn't want me to tell you, I'm now going to say, ladies and gentlemen, the black box in the aeroplane proves that the aeroplane is not following a curved trajectory at all. It is flying horizontal from its departure airport to its destination airport. There is no curved trajectory. That's the end of the globe right there. Okay? So all your inertial, blah, 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 gobbledygook nonsense that you mentioned is totally smashed up by the pitch data. That's the angle at which the airplane is flying during its flight, the behavior of the aircraft in the air during flight. It is not curved, as I said earlier. If it was following a curved trajectory, your cabin crew would not be delivering to you your drinks, snacks, blankets, pillows, magazines, newspapers, and your meals. Everybody would have to be seatbelted up because the aeroplane is not flying horizontal. It's going through a curved line. But indeed, you do get all your snacks and your refreshments, and you can stretch your legs because the aeroplane is flying horizontally. That's what the data shows as well. Thank you.
Checkmate, Globies. You get your snacks on the airplane, so that's pretty solid evidence. I'm curious.
Game over.
Boom.
Game over.
Oh.
Game over, Globies. You get your snacks. There's no curve. You heard it here.
If you ate a peanut on that plane, that's it. One peanut.
That's it, man.
That peanut would have flown off the earth if it was really spinning.
Yeah, it's true.
Sorry. I just imagine myself on the plane again, and we had turbulence and all the fish crackers going on the floor and everything, and me screaming bloody murder. And Jen's like, "Yeah, you wouldn't be able to do that."
Jen just cracks me up, man. I love you, Jen. Never change. Never change, man. We don't agree, obviously, but you know. I hope that you get a TV program one day. I think you'd be a really good presenter. That would be fun.
Jen could be a cottage industry. T-shirts, licensing, magazines.
Yeah.
I'm telling you, branding. It's all about branding, y'all, around here.
Did you know he was a great baker? Did you know he was a great baker? You had no idea.
I mean, Nathan Oakley 2024. What am I going to have? Stationary movement. That's right. I forgot.
Yeah, what's up, Joe?
Morwan, have you like considered in terms of the whole like airplanes and all of the navigation and the GPS and all these factors? Have you I mean, outside of just having a position of the globe information, but have you considered like how these systems could be compartmentalized? Yeah, like the compartmentalization and the way the equipment is designed, and then the way that there's the civilians at the level that are running the equipment, the higher ups in the GPS, the folks that are programming that. I guess my question is like, have you considered just for like just in the thing of like setting the globe aside for a second, being like, okay, if the Earth actually is a stationary plane, how are they pulling it off? What would they have to do? Where would that this team is doing the GPS, that could be transferred off to this team that made the equipment. That would have. I'm just wondering if you've considered like from the like in a detective sense, like okay, if the Earth really is stationary and planar, how could they? How could how could that be woven to be happening?
Sure. Well, the issue you're going to have, Gio, is that like the fundamental properties of gyroscopes. We've moved to ring laser gyroscopes, and I think it's easier to make an argument for. I'm not saying you take this position, and this is more something that like Alan and Shane argue, for example, or Dr. Bennett, for example, who I've talked to on this subject. We'll be on Flat Earth Fridays. In about 14 hours. Alan wants to talk to me about the Sagnac effect again, so if you are interested in this topic more, we'll be talking about it then. But I mean, the issue that I have with that, Gio, is just that there's like fundamental physical principles that I don't think you can really hide. Like I was talking to Indio about this on Twitter, and I kind of got him to agree, and then we didn't really get any further than that. But like, if you had a sensitive enough gyroscope, like mechanical gyroscope, you could bring it on the plane, and you could verify with the level that you're flying level the whole time, and you're going to detect a drift in that gyroscope. Like you're going to physically see the gyroscope drifting. So, in terms of like compartmentalization, like how do you hide that? You know what I mean? And then what could possibly like I can't think of a way to steelman that on
Ether. Ether drift.
But for a physical gyroscope though? Like I get it, yeah. A ring laser gyroscope, like you can make an argument for that. Like I can steelman that, because if there was an aether vortex and there was an aether wind and the luminiferous ether, or whatever kind of ether you want to describe, affects the propagation of light, then yeah, you can develop a model. I mean, the originator of the Sagnac effect derived the Sagnac effect trying to disprove relativity in favor of an ether, right? So it makes sense mechanically in some. I don't think it's correct, but it at least makes sense mechanically. I struggle to see, to be honest, how a physical gyroscope can be like pushed by an aether, and that push wouldn't cause like other things to also get pushed. Does that make sense?
Yeah, but I mean, if it's made of metal, and then we're in there's an electromagnetic field of the Earth and the medium and everything, and it is made of metal as well. I'm not just saying it's like direct, I'm not just saying it's a magnet that attracts metal in that exact way, but just the fact that it's metal. And then there's like the Foucault pendulum precession process, and then the Sagnac effect, and then the Coriolis bullet drifting, and so on. And I know that there's different. Some people say like, no, those don't exist at all, and there isn't that at all. Others will say, well, actually, it does exist on a stationary planar surface that accounts for these effects. So yeah, I mean, if ether wind is the cause of all of those, just saying if at the moment, of the Foucault's pendulum, etc., all those I named, then how could it? Just with those tenets, how could it not potentially also affect a mechanical gyro?
Because I just don't see any physical mechanism that it would communicate with the gyroscope. That's the issue that I have. And it's like, it's simply explained. Like if you take a gyroscope and you put it in a laboratory and you put it on a rotating reference frame, you will see the precession occur much faster. You know, you can spin it to like, I don't know, 1 RPM, and you'll see the precession at a rate according to that rotation. So to me, it's just like, you know, we have a proven effect in the laboratory. It's isolatable. It's explainable. It makes sense as to why that happens from a sort of mechanics and physics point of view. So to me, that's the consistent explanation for why these things occur.
Well, from the perspective of like, okay, so let's just say that you knew in the future for sure the Earth wasn't rotating. Like you had absolute other tests and that was for sure. But these effects were still happening, the gyro, the ring laser, Foucault's pendulum. If you knew for sure the Earth wasn't a spinning sphere, what would you be left with at that point? Like, would you be like, okay, it has to be something with the medium. Maybe we don't fully know. We don't have the detection, whatever it may be, but is that where you would go at that point? If it's for sure not Earth rotation, would you be left with
Yeah, there would have to be some sort of effect like that. I think honestly, if I were to like completely steelman it in that regard, I think but then you run into other issues, right? But like the best explanation I can actually come up with is that, do you know what the Lenz-Thirring effect is? Have you ever heard of that before? So that's a relativistic, like space-time effect on gyroscopes, which causes precession. That would honestly be where my mind would go to. Is there some kind of effect in space-time, and like rather than the rotation of the Earth, there's a rotation of space-time, and that's what's causing the gyroscopes to precess, because that mechanically makes more sense to me, because the geometry of space-time can affect a physical system like that in a way that I struggle to see how a like aether medium could, if that makes sense.
All right, I hear you.
That's where I would go, honestly. But the issue is you know what's measurable and empirical and stuff like that. But yeah, if you were to say like, okay, you prove to me that the Earth doesn't rotate, you've proven it with 100% certainty, and you're like, hey man, the gyroscopes still precess. That's where I would go to try to drive the effect.
I just want to point out, I've seen mechanical gyros time lapse of and not showing the drift.
Yeah, well, I mean, it's a known effect. It has to be accounted for. It's been accounted for. I can show you references from Global Navigation for Pilots where they clearly explain the effect. If you don't see that effect occurring, there's a level of precision in gyroscopes, and the level of like toy gyroscopes I don't think are precise enough to pick up on that effect.
But what I've heard too is like the early days in plane flights, you know, they had just basic gyroscopes and they didn't account for it. So, and then all of a sudden we started accounting for it. Like, I don't know,
I don't think that that's true, because the earliest gyro compasses rely on Earth's rotation. Like the only reason that gyro compass and FE Core demonstrated this in their gyro compass experiment, you know, and Bob Nodell and you know, rest in peace, Bob. I don't want to like throw shade on Bob in any way, but like, they found, you know, they did an experiment with a gyro compass. They took it apart, they put it back together because they couldn't figure out how it was still working in the way that it was, and they found that it was consistent with a measurement of Earth's rotation. Now, could there, you know, there's always the possibility of being some other effect that we're not accounting for or observing, but like, yeah, it's like, if you take a precise enough gyroscope and you place it on a rotating platform in the lab, you will see a rate of precession that is precisely equal to the rate of rotation. So that is the simplest, mechanically explainable explanation for the phenomena of gyroscope drift. Yeah.
But what about when Bob said he like took it to different elevations and got different readings? And
I mean, I just need to see the data. I mean, so Dr. Bennett has suggested that to me as well, that there's a what he calls a elevation dependent effect on the ether wind. You know, and to steelman that, Dayton Miller also recorded. Are you familiar with Dayton Miller's interferometer?
Oh no, I'm just,
Yeah, well, Dayton Miller basically was an ether guy, and he was one of the. He was a serious scientist. Like, I have a lot of respect for Dayton Miller. He put a lot of work into his apparatus. He tried his best to isolate it and to make it a good measurement. And he claimed to detect a difference in the what he was measuring as a claimed. I don't know if you know how interferometry works, but like basically when you overlap two beams of light, there's constructive and destructive interference, just like ripples on a pond. And that constructive and destructive interference will cause what's called like a fringe pattern. And basically, if it's moving, we notice a change in the fringe pattern. And then there's a difference of explanation between ether theory and relativity as to what causes that fringe shift. And Dayton Miller was of the camp that there was an ether wind. And let me find actually, because
He was a great amateur flutist as well. So I think probably something about like understanding the fluting of these ether winds.
Nice.
play the flute.
It seems appropriate.
I guess for me, where I'm at now is, the mechanical gyro is claimed to pick it up. I just need to see that like repeatable in multiple tests, which I really haven't seen.
Also, like the friction. There's like friction involved and all the motion. It is kind of there's a lot of movement going on.
Sure. Yeah. I mean, I could provide you with plenty of evidence of that. Again, like FE Core commissioned a build of a gyroscope themselves, and there was issues with the ball bearings, Geo, to your point, and they weren't initially picking up the rotational rate as expected, and then they fixed the gyroscope bearings, and they did measure a rate, and I have messages from Bob, confirming that this was measured. That I've gotten from other sources. Obviously, I don't want to put Bob on blast and anything, in for respect for him and his family. But like, this is something that is, when you have a precise enough system, the effect always occurs.
But what makes it precise? Like, what are we talking about? The RPMs or?
I don't. That's beyond my pay grade a little bit. It would have to be a level of like, I think RPMs, and then like isolation from the environment, the ability to, but I don't, I'm kind of just spitballing, to be honest. I have to get back to you on that and do more research. It's a good question though, for sure.
Yeah, because well, I just find it odd you're saying precise, but you don't really know what
Yeah,
it means.
yeah. Well, I have the raw data from the ring laser gyroscope that the famous one, and the work that Bob and his team did on that. So, I mean, I could certainly share that at some other date, but the ring laser gyroscopes are by far the most precise these days. But then, we get into the Sagnac effect and differential interpretations of the Sagnac effect and special relativity, and it gets extremely complicated extremely quickly.
Someone posted a graph of the ring laser gyroscope data, and it varied between 14 and 16 degrees. So I'm just like, if this thing's so precise, why is it varying between 14 and 16? Shouldn't it be like spot on 15 or?
That's a good question. Yeah, no, there would always be some level of variation because there's something called angular random walk in gyroscopes. So any instrument is going to have, you're familiar with the difference between signal, bias, and variance? Like those three components?
I'm guessing, I'm guessing there's very technical aspects of it.
Not particularly. It's like, so you have like a Rambo picture. Are you like a shooter at all?
Nah, just in games.
Okay, fair enough. But like, basically, if you think about like shooting, if you were at a range and you were shooting and all of your shots were going left, and I'm not super big into shooting. I don't know if that's really something that even happens, but like, for the sake of argument, let's say that's happening. That would be called bias because your shots are systematically off. Now, if your MOA or like your spread is bigger, that would be variance because it's like a variation around where your shots are going. And then the signal in this example is where you actually want your shots to go. So all instruments are going to have a signal and an error. no measurement is going to be 100% precise. And so there's going to be a bias term, which hopefully we get as close to zero as possible, because we don't want our instruments to, if we have a bias in our flight system, well, we're going to persistently be 50 miles off from the airport when we land, and then we have to, make an extra turn or whatever to get to the airport. But there's only so much you can do to reduce variance. And ring laser gyroscopes, and I have one of these manuals that describes this on my server, but basically they have what's called angular random walk, which is, that gets more technical, but basically all it means is that there's a error that accumulates on a minute to minute, second to second basis, and that error will accumulate over time. So even over an hour or 24 hours, just because of that random error, there will be some deviation from the expected rate of rotation measurement. It's never going to be perfect, basically, because of that.
Yeah, because it would have to be, because after a 10-hour flight, you don't want to be 10 degrees off or something.
Yeah, exactly. So you want the ability to deal with that error. And so while we know that we're going to be measuring on average a 15 degree per hour drift, and we can measure that in the systems, you can often, and this is maybe where you might say, oh, well, we're presupposing whatever. If you expect a 15 degree per hour drift, then you can add that in as a correction term to the system. And basically the difference between your true position and the expected position is then going to be corrected automatically for the drift due to rotation. And what's left over is just going to be a small amount of error, which will accumulate over time. But there's also error correction algorithms and then things like the Kalman filter that deal with that. So it basically, you can essentially detect the noise versus the signal, and you can sort of differentiate for it. But that gets a lot more technical. I have a, let me find a whole folder on inertial stuff. Let me try to find this for you. Because one of the things I'm thinking about doing is actually doing a measurement of Earth curvature just based on an inertial system. And so here, for example, I just posted it at 5:07 my time. This is this is a simplified diagram. There's even more corrections that are shown here. But these are all of the different steps that are done to compensate for all of the different factors that are going into play.
Yeah, it's very technical.
Yeah, it kind of is. So, but does that help? I don't know. That's why, because you have really good questions. So I appreciate that. Because you would expect a bang on exact measurement, right? But in general, that's not how things work.
I guess that's why I come back to mechanical gyro, because that feels a little bit simpler, and that the claim is they're picking it up too. So.
Yeah, definitely. So that's the strongest evidence for me is that it's not aether wind, is that I can reproduce this effect in a lab in a way that I can't for any sort of other cause. And nothing is perfect in science. We don't prove things in science in the way we prove things in mathematics. And if anyone's recording or watching the stream, clip that and send it to the Bevites, and they'll have a field day with it. But yeah, that's my position. So we do our best to assess causality, and the issue that we run into, which is something I've become more aware of since I've started talking to people in this space, is that when you don't have a controlled experiment, it's a lot harder to assess causality. But my point is that when you can take an effect and measure it in the laboratory, I could put a gyroscope of sufficient precision on a rotating platform, rotate the platform, and it's going to precess in accordance with the rate of rotation. And then I put the same gyroscope on a non-rotating fixed reference, and I observe a precession that behaves the exact same way. The simplest, consistent mechanical explanation is that the entire reference frame, in this case, the Earth, is rotating.
Yeah, but that's still a logical leap. I mean, I
Sure,
understand like the idea to
Yeah,
kind of default to it if that's your like, you know what I mean? But if we're being really rigorous in terms of, what the truth is, it doesn't like that doesn't necessarily
Right.
least
So
that-
it could be other things, but we don't have any other coherent explanation. Like if someone presents a coherent, like to my mind, the ether wind has never been experimentally demonstrated, and there's other explanations for Dayton Miller. Like there's kind of 3 layers of explanation for Dayton Miller. The first layer is, oh well, he just didn't set up his apparatus right. I tend not to use that because I don't think people would find that a compelling argument in this space. The second one is that his data processing created a signal where there was none. Again, I don't think that that's that compelling of an argument in this space. So the one that I tend to go with is what's called this gets way more technical, but there's something called the quadratic Sagnac effect, which explains Dayton Miller. And that's kind of the argument that I go with in that regard, is it goes both ways, right? Because if you say there's an aether wind, well, demonstrate it empirically and provide a coherent explanation. For me, the evidence for a mechanical effect of the rotation of the reference frame is more supported because I can demonstrate it by experiment with independent and dependent variables and everything being involved. I can't do that with Aetherwind. I've never seen that done with Aetherwind. And if you have those experiments, I'd love to see them. I mean, I am biased. I'm not going to say I'm not biased, but I would say more than many, and even a lot of the people on my server, I'm more friendly to alternative explanations, I would say.
Yeah, I guess for me, still, the mechanical gyro has to be repeatable, and I just haven't seen that. So
Yeah, that's fair, man.
kind of where I'm at now. Where it's like it's already been proven to you. Again, all this is because at the end of the day, it's measuring curvature or not. Okay, it's just like, okay, the gyro spins at 15 degrees, but what about if we measure the surface as flat? Like, now what?
Yeah, well, the issue then we get into like measurement versus calculation and then a lot of other things, right? Because to my mind, the surface doesn't measure flat, and I've seen extensive evidence to that effect. I have a geodetic surveyor on my server. You might know Shoebill. I don't know if he doesn't usually hang out here. I'm trying to get him to like engage with people more, but he hasn't been responsive to that yet. Because he's done extensive measurement of the Earth's curvature, and he has training and like 30 years of experience. So, and he's done a ton of different ways: zenith angles to the sun, reciprocal zenith angles to objects at varying heights, drop over distance. He's done tons and tons of measurements. So, I mean, I can personally tell you 12 probably measurements that I could provide you with data on. 6 to 12, somewhere in that range, that have been done by various people. So, but then it's a question of like what measurements you'll accept, right? Because the common concern I hear people have is, well, are you just taking a flat planar measurement and adjusting it to be spherical? Right? I don't know if that's something you subscribe to. I'm not trying
And
to.
the answer is yes.
Well, that's the argument being presented is
Right.
taking the measurement and putting it through a maths formula to give you
Yeah, man, I disagree on that. I mean, I think that the demon
it's
dark matter.
It's like, are they or are they not? It's not a matter of opinion. Are they putting more? Are they putting it through it?
Oh, demonstrate dark matter. Sorry, Ricksky. Someone tagged me in the chat.
I've been interested in geodetic surveys, and they take the measurement, and then what do they do after that? Do they put it through another formula, or?
Well, I mean, that's the thing, right? Is like you need to do certain calculations. I mean, it's just simple like a reciprocal zenith angle measurement, though, is just very simple trigonometry. So to my mind, that's not like, huh?
Is that the more than 180 degrees thing?
This is kind of getting out of my comfort zone, so I would probably have to defer to other people. I don't know this area that well.
Is it possible that you don't know it well enough to like adequately understand if it were debunked to you right now?
No, because I've heard the arguments against it, and I've heard the arguments for it, and I find the arguments for it more compelling. Like speaking to Shoebill, for example, he's talked to me quite a bit about it. I just don't have. I need to look into it more. Like my area of expert, like as like this side of the debate, like I understand like the inertial nav stuff very well or fairly well, like gyroscopes, relativity, like that side of things. I haven't got, and this is probably something that I should work on. Like I'm planning to get a theodolite and do the measurements myself anyway, so that's ultimately the proof in the pudding. Like I've talked to Jesse and Shoebill about, there's 3 14ers in Colorado, 14,000 foot mountains. Pikes Peak, Longs Peak, and what used to be called Mount Evans is now Mount Blue Sky. And the plan was to do 3 simultaneous reciprocal zenith angle measurements from all 3 of those peaks. That would be a pretty cool measurement to do, I think.
That would be a cool exercise in mathematics.
Yeah, I mean, that's the thing, right? You can say that, but it's like
one does not observe a reciprocal zenith angle; one calculates it.
I wouldn't disagree with that.
Visual proof of reciprocal zenith angle. Like you cannot pictorially display it. It's not a graphical element like that.
Yeah, but I mean, what is your?
It's based on over-spherizing. It's over-spherizing the whole observation, because you're taking your relevant local data and then you're like also like placing that on top of the curvature.
How though? Where does the curvature enter into it?
Well, it's like if you, it's like saying like you have a peak, like a triangle that occurs on the topography of a sphere, right? And from that we are able to get sphericity, but then we also have the angle of the peak. So that's why this excess can occur, and that's been like kind of shown from Bacon to me. Like I think Bacon's proved that.
Yeah, I'm not sure about that. I mean, my understanding is that it's just the main issue would be the need to account for terrestrial refraction, and the terrestrial refraction, in some sense, has a radius value, I think. That's probably where that comes into play. But I believe that there's still a drop over distance inconsistent with but that's why like I'm also thinking, and maybe this is like me being arrogant and just trying to like reinvent the wheel, but like I actually am coming up with a method to measure curvature using a gyroscope stabilized platform without relying on any sort of external reference, which would just be based on calculating a deviation from local vertical. I guess that's a calculation again, though. So it's like that's the problem you run into. If you exclude all calculations, it becomes really difficult to measure things.
So if we're just observing the land immediately in front of us, and even setting up the tools to measure these things, we have to ensure that we have level in common with all these things, don't we?
Well, level varies over distance. That much is clear.
But again, I'm saying to you that if I'm standing in one spot, right, and right in front of me, my little spot that I'm on, I'm like, oh yeah, I got level here, or I've taken, whatever tool it is that I'm using and able to calibrate level, right, recognize level locally. And then I go to a spot that's 100 miles away from me, right? I know that I'm observing that spot off in the distance that I want to go to, that you're presupposing there's a curve over there, right? So I'm going to update. I'm going to go to that location, and all of a sudden I'm verifying that curve exists there as well, right? So my question still remains from an hour ago, right? I've gone swimming in a level local swimming pool, an Olympic-sized swimming pool. Now I'm finished, I'm back, and I'm asking you, how is it that we can observe level in all these different places, right? And then when we administer the dimension that y'all claim, we don't find that drop over distance.
But we do find that drop over distance.
How? Give it to me. How?
Do you want to see some measurements? I have measurements. Do you want what angle? What method would you prefer? I have reciprocals. I have zenith angles to the sun, corroborated by the raw ECF coordinates of GPS. I have reciprocal zenith angle measurements from a variety of different people. Like, what measurement would you accept? Because
I would love.
Wait, hang on a sec.
Okay, go. Sorry.
Oh, Blotech,
So 1
for
second.
fuck's sake.
Did you say
Oh
you've got
my
zenith
God.
angles from the sun?
Blotech, please, can you just not?
Okay, wait. I thought
Well,
you said
yeah,
the sun,
I mean-
the Earth's spinning 1,000 miles an hour. There's no way you could get an accurate measurement.
Well, hold on. I'm trying to
Garbage.
hold him. I'm trying to hold him to the surface versus going to celestial objects, right? So I'm allowing him his space, right? So allow him. We're asking about the surface, not the stuff up in the sky. We're asking about the surface. That's what I'm asking for. A 100-mile sample set that shows a 6,600 foot drop, because that has to be there in order for the. Hold on, I'm not done yet. That has to be there in order. Wow, I'm so okay.
That big clap of thunder. That's when he came in. Oh, okay. But call him. Oh, come on, Jack.
Here, I got some for you, buddy.
Go. Hold on. He was just hot miking, Killian. If you want to finish.
Thanks, Brother Gio. Yeah, I'm just looking again. Here's what I want from you that I would love, Sea Lion, is, right? It's 100-mile sample set. Anywhere. You can go to Australia, Canada, wherever you want. I would like to see, even over water, a 100-mile sample set that shows us a 6,600 foot drop over that distance. Go ahead.
You require it to be 100 miles specifically with 66 feet of drop?
No, 6,600 feet.
Oh, I'm sorry.
100 miles, a
yeah.
6,600 foot drop. That is literally if P then Q, right?
Right.
If
Hold
we
on,
have a 100-mile distance that we can observe, then we would see a 6,600 foot drop. If we don't see that, then the Earth that we're investigating cannot be a ball. If P then Q, if no P then Q can't be the case. Go ahead.
All right, hold on. I got you, fam. I think I have that for you, actually. Are you cool with a single measurement? Like, what are you looking for here? Like, how many measurements are you looking for? What type of measurements?
Brother, you would have to show your starting point, right? We'll call it let's call it, if we were to do it in a graphing measurement or a graphing way, we would say X is our starting point. A would be at one point, right? And then when I get to point B, I go to the next point on the basketball 100 miles away, there would be an elevation difference of 6,600 foot drop while observing level at the same time.
Okay. I'm not sure if I have that exact number though. That's the issue.
But that's what we have to get. And again, that number can vary, 100, 200.
Demanding
right?
100 miles. Why is that required?
Because that has to be there if you're going to say it's a ball, brother.
Okay, but what's the issue with doing that measurement? It goes the other way, right?
No, it doesn't.
Okay, but if I measure drop over distance over a smaller amount, your flat Earth is falsified.
No, it's not, brother. Again,
Really?
you have
Really? Are
to,
you sure
right?
about
Again,
Let's think about
right?
that logic. Here I go. I've got a measurement.
Brother
I've got a
Sea
measurement
Lion,
over
brother Sea Lion, I'm keeping
Yes,
you
sir.
honest, right? And I'm saying to you that I'm observing level locally. This is fact. You then
Yes.
have to prove how you're able to go to those 2 points, observe level, and still
There you go.
enforce a foot drop over that distance that you're observing. Now that you can go bigger than 100 miles. The problem is when you get bigger than 100 miles, the drop gets more and more substantial. And pretty soon you're literally looking at upside down people.
Okay, well then, I mean, don't be silly with upside down people. Come on, let's
Brother,
take it.
that's your claim. Spheroid
No,
claim is upside down people.
Nobody's upside down. You have a fundamental misunderstanding of the gravity vector because of your day-to-day experience with gravity always being downward. And this is again the issue that you're having. You cannot apply the scale of what is in the room with you right now. You are making a fallacious application of that scale to the scale of the planet. Now
Nope.
I'll provide you with the measurement that I have, the longest range one that I have, which is 182 miles.
So 182
And
miles,
there's
that
a
would
1 degree. There's a 1 degree drop, as measured here. So this is an observation right here. A measured drop of 19,740 feet.
okay. So you're measuring level at the top of that mountain, correct?
Correct.
And then
Yes.
you're measuring level at that other top of that mountain, correct? Correct?
You are measuring.
Yeah.
Am I coming through?
Are
Or
you at the,
Oh,
are you
sorry.
at? Are you suggesting I need to go to the other mountain and
measure level.
simultaneously measure that it's level? I'm not
You have to-
understanding that.
you have to orient up, you have to orient plumb, you have to orient level at both points, right? You have to, because we observe level locally. Just because you think that you're standing at the one mountaintop and that other mountaintop is at a disadvantage just because you're looking at it, no, you have to state what it is locally at that mountaintop level. Then you have to go to that other mountaintop, observe level, because that's a local observation. Then you have to prove your mathematical drop over distance in order for the spheroid claim to be true, right? You can't make a claim on another spot that you're viewing off in the distance without without significantly investigating and ensuring that that spot that you're observing also has the required information. You can't just say, look, there's a duck 100 miles away and say that there's in fact a duck without investigating the fact that the duck's there. Go ahead.
That's kind of a silly example, but
No, it's not. It's perfectly real. Go ahead.
In this case, so we have observed that we're measuring from a level station in the first observation point. We're measuring a drop over distance consistent with the globe model. What is your objection to this measurement? I don't understand your good faith objection.
Okay, let me ask you this. You set up your observation spot. What are you observing that first spot with? Mount Ellen.
Mount Ellen, yeah.
What are you using to set up your experiment or your observation? What are you using to set this up?
I didn't do this measurement personally, but you can easily level the instrument and then use any sort of optical instrument, theodolite, and level it out, and then measure. Like I said, I don't do these measurements myself.
Okay, so we're investigating something that you didn't do, so you're inserting something as an authority, although you can't take an authoritative view on it because you didn't do it. Is this correct?
You asked me for the measurement.
Yeah, and you're what you've provided, your evidence is crappy. You can't even stand behind your own evidence that you're supplying.
Well, do you believe that this measurement was done incorrectly by the person that did this measurement? I can provide you.
I would need to speak to them. I'd like to ask them a question.
Okay, so I think the more productive thing would be for you to speak to them directly. Would you commit to that?
But here's the issue, right? You and I are engaged in a conversation right now, and I'm stuck on the point of stating very comfortably, right, that every single built form in this place is built observing level. Right? Not measured, not calculated, not used a formula, right? No, I'm not holding up because I'm saying to you, I'll be finished with my point in a second, right? We observe. No, I'm not making fallacious.
Yes, you are. You are assuming you've made measurements. How do you know that the level point is the same between those measurements? You're assuming that that's the case. If I tell you, measure level with the spirit level at point A, point B, and point C, how do you know that those 3 points have the same level? How do you know?
Because I can use an instrument called
how do you know? You have no way of measuring that. Are you going to assert that you have some way of measuring it? Personally?
Again, I can appeal to any single built form built in this realm. I can take any. Oh, so you can finish and I can't?
No, sorry, Killian, go ahead.
Right. So I can firmly state I can go to any building built anywhere, Australia, Alaska, Canada, Tokyo.
Shout out to Australia.
Observe, shout out Australia. Observe level locally with any size level I want. It could be 12 feet, it could be 20 feet. I can take a steel girder, take a cup of
How about a
water,
mile?
put a black line on it, right? Observe level on that steel girder that could be 30, 40 feet in length. That maybe goes in an apartment building, right? Observe level and then update that location as I go to each different built form. So again, I'm
Yeah,
going
but
to
you're
ask you,
assuming-
if I take
No,
two
hold
built
up.
forms,
That's
hold
the
on,
problem.
no,
No,
B.
that's the problem with your fallacious reasoning. You have no measurement between them that connects those level lines.
Well, if
You're
you
making
allowed
an
me to
assumption.
finish, if you
You're
allowed me
making
to
an
finish,
assumption. You're making
you
an
allowed me-
assumption. Okay, then prove me wrong. Show me your
Right.
measurement.
I
Show
can
me a
then-
measurement of the continuous level line between those level
Show me
points.
your measurements.
brother, I just did. I told you all the
didn't.
buildings, right, are
No, you didn't.
wow.
You have no.
So
you have no way. To
you don't
connect
listen
those
and you don't
measurement
let
points.
people finish. I'm out. Y'all be good.
No, I'm just pointing out that you are making an assumption that those individual measurement points that you have made maintain a single level line that is horizontal between those 3 points. And that is simply an assumption. You have no measurement of the correspondence between those measurements of level.
Right. Now, we go to a Google search and you can search the distance between any major city in the United States of America.
How do you know the
can,
distance? How do you know the distance?
Can I get some active moderation on this? Because like you're just on an absolute you're talking like you drive. I'm imagining you probably cut people off left, right, and center when you drive too.
I'm a little bit of an aggressive driver sometimes, yeah.
Ah, so you're an aggressive driver and an aggressive speaker. Is that correct?
Well, dude,
Sometimes.
things were going
When I need
smooth
to.
and things were going fine
When I
until the
need to
last
be.
5 or 10 minutes. Can you just let him say his point, Mordwan? Just let him just have a back and
Yeah,
forth.
I just, yeah, fair enough. Go ahead.
Can I just touch on?
Well, it's just like the audience wants to hear both sides. So it's like if you're cutting him off because you feel like your point is more important or whatever, then he's just getting cut off. The audience can't really hear the conversation. So just
Yeah,
back and
fair.
forth so we can hear both sides.
Can I
But what's
just
the
touch
difference?
real quick on his orthographic view measurement?
Yeah, go for it, man.
Because I've done extensive talking with Jesse on this, and if you can see in the chat there, with
At
those
531.
with those orthographic views, once stuff gets beyond the horizon, it starts having this bottoming out effect. So we're taking this optical view and applying physical attributes to it. So, and I know a lot of people don't think things can bottom out on a flat surface, but this is just an argument I think needs to be presented.
Right.
Okay.
And that's called compression over distance. So as you view things off in the distance, if they're closer to the floor will effectively eat that item from the bottom up. If the object's closer to the ceiling will effectively eat the object from the top down.
Show me.
Compression over distance. I show you nothing. You showed it yourself in your own observation and electricity. You just pointed it out, brother.
No, I didn't.
Jeez.
Show me an object disappearing bottom up on a flat surface.
Let me get it 1 second.
Without the camera being below the table. No
This
trickery.
is in a hallway with the light at the end.
All right,
and
let's see.
again, yeah.
So, but here's the issue, and the reason I was asking you about distance, Killian, all of your distance measurements rely on a spherical Earth.
No,
the
they
correct
don't.
application of the spherical Earth. Yes, they do.
Okay.
Every day, every single distance measurement you have ever interacted with in your life is a spherical distance measurement.
Holy
You
crap,
use
dude.
GPS
Oh,
every
wow.
day. Use GPS every day, which is a spherical system. There's no way around that.
So you take your presupposed truth and you just stomp it down people's throats?
No, I just point out the inconsistencies in your bad faith representation of standards of evidence. That's what I do.
See, the problem is you can't call my argument a representation of bad faith. And that's where I have a huge problem with you because you too, Sister Be Well. That's where I have a huge problem with you because you're taking my entire argument and you're putting this big lasso leash around it and you're saying that it's false, right? And I have a problem with that because, again, any built form shows you level in this realm. and that is not.
You're missing.
Wow,
you're
bro, you
missing the argument.
suck. You really suck.
You're missing the argument. You don't have any measurement between the points that connects them in a single continuous level line. You're just
Yeah, I
assuming
do.
that it exists.
Yes, I do. I've got
Show me.
distances between all the major cities, right? And again, all the built
Measured on a
forms show
globe. Yeah, thank
all
you.
the
Welcome to
built
the globe.
forms, all the built forms show levels. So again, I'm going to ask you and keep beating my drum until I get a 100-mile sample set that shows me a 660-story building being dropped into that distance of 100 miles. You can go ahead and demonstrate that, Spheroid boy.
Oh, sure, I will, but it won't make a difference at all because then you'll just move the goalpost to something else, and we both know that that's the case. We both
Still
know
observing
that.
level. Still observing level.
Everything you presented, your distance, you cannot show me a distance measurement that does not rely on the spherical geometry of the globe. Show me it.
You're presupposing.
No, I'm not
it's a
presupposing
sphere.
anything. Show me.
Yeah, you are.
Show me your distance measurement that does not rely on a spherical geometry. Every single observation that you have done relies on a spherical geometry of distance. And the argument that curvature is optical is falsified by the way that all flight planning, all navigation, all systems thereof are calculated using spherical geometry. So if it were the case that it was purely optical, why would it be the case that every other system of measurement reproduces that same value of curvature, even when it has nothing to do with optics, like the Schuller oscillations and inertial navigations? No optics at all.
So what are
Explain
you
that.
using to produce your curvature numbers?
There's many different sources.
Give
There's
me one.
the ECF, the raw ECF coordinates from GPS, which anyone can gather. Easily, you can calculate it that way. You can reproduce it, and I'm planning on doing this by pulling the angular torque rate of a inertial gyroscope stabilized platform, and you will find a deviation from the vertical. That's another way.
So how
Third
many?
way is measurements
Oh,
of drop over distance in geodetic surveying, and I have many such measurements to show you. I'm not a geodetic surveyor, so if you'd rather talk to someone more qualified, I'd be happy to set that up for you.
Okay, so you can appeal to an authority, but I myself, as inserting myself earlier, in which I appreciate Riggs for creating that survey to check the crowd to see if my 30 years of construction experience would be valid. But my experience is not valid, but your authority's experience that props up your globe is valid to speak against me.
Your experience has nothing to do with the shape of the Earth. So it's completely irrelevant.
Again,
I'm not
the
making
construction
a authority. I'm giving you measurements.
Just to steel man what you just said, you're telling me that my experience has nothing to do with the shape of the Earth, although the construction industry builds on the Earth.
So what is the largest project you've ever worked on?
What is the largest project I only do residential projects.
So then it has nothing to do with the shape of the Earth, does it? You pour concrete in someone's driveway and you think you know something about the shape of the Earth? That's ridiculous.
If I can ask a question real quick, how does the distance of any 2 points have anything to do with the Earth being a globe?
Great question, because if it were the case that the Earth were flat, the distance would be calculated in a completely different way. Do you know how the distance between 2 points is calculated on a great circle?
Well, there are
question,
1,609 meters in a mile. So
Yeah,
if we're
but you-
calculating distance in like how we do in North America, I'm not sure if Europeans in here, but in miles versus kilometers, I don't understand your point you're trying to make that somehow the amount of miles or distance between point A or point B would somehow prove that the Earth is a globe when it's just a measurement of how far you have traveled.
Yeah, great question. So, do you know what the Haberstein formula is?
I'm not familiar.
So the Haberstein formula is how we calculate distances between 2 points. Oh, sorry, wrong. This is the measurement again. How we calculate distance between 2 points on a great circle. So let me just explain to you why this only works with a sphere.
Well,
If it
hold
were
on before you go forward. I'm not asking in terms of a great circle. I'm talking in terms of just measuring the pure distance that you've
That's how
traveled.
it's done.
It's
That's how
in
it's
it's
done.
in. I mean, no, it's not. It's just literally measured in
Well, when we do an
miles or
airflow,
meters. It's not. It's you can even, if you really want to get technical, you can put a ruler down and make it really like yardsticks
and
and
what you
like
will
literally
find,
measure a mile with it.
you will find that it's consistent with the Haversine formula and great in small circles. So when you plan a flight, they don't just wing it. They bring the exact amount of fuel that they need to get from point A to point B, and then a margin of error.
But that's not the
distance
question
will not-
being asked.
Yeah, but I'm trying to explain it to you. I'm trying to explain it to you. So when we go from point A to point B, if we were calculating the distance incorrectly, if it was not using the spherical geometry, there's two different measurements here. The fuel is providing us with a measurement of distance because there's a burn rate at a certain miles per hour, and then we know we've traveled a certain amount of distance based on the burn rate of fuel. That precisely matches the rate of burn using the Haversine formula on a great circle, and not any formula that corresponds to a flat Earth measurement.
Yeah, but that's just
If you were-
fallacious because you're saying that the distance that they use, the way
What's
they
the fallacy?
calculate the distance. Excuse me?
What's the fallacy?
Dude, please don't interrupt. Just let her finish.
Oh, she's saying my argument's fallacious. What's the fallacy?
I know, but you gotta let her say her full point, and then you can ask the fallacy because now it's just interrupted, and she was interrupted.
Okay,
Just let
fair
her
enough.
finish.
She was just about to lay it on you, dude.
All right, sorry. Go ahead. Tell me the fallacy.
Well, first, let me finish my statement. My statement is that the distance that is traveled is irrelevant to both the globe and the flat Earth because it's literally just a measurement of how far you travel. Like I said, you can literally measure it in meters. It has absolutely nothing to do with the shape of the Earth at all.
You're just saying that. Is that just an ipsy dixit? Do you have any proof? Do you have any logic?
Do you
have
know
anything
what a
behind that
ruler
whatsoever?
is? Do you know what a ruler is?
Yeah. So are you saying that I can physically take a ruler and measure miles and miles and miles of distance? That's
Yes,
absurd.
it would take a lot of rulers, but yes, you could because it's a measurement.
So go do it. So go do it. Show me.
What are you saying? It's hard for somebody to go outside and measure a
saying
mile? Is that what you're saying right now?
I'm saying that what you are describing. So if you take, so there's a lot of different ways you can measure distance. Odometers are another way. Again, when we do that, all measurements will correspond to the Haversine formula of the distance between A to B, which is a spherical formula for measuring distance. There is no formula you can provide me with, and no one in the chat can do this, can provide me with a consistent formula that works everywhere on Earth for a flat Earth measurement of the distance between points A and B that is not using a spherical geometry.
Yeah, I got something for you. It's called a ruler.
Okay, so just go and find, then lay it down for me. Show me. Otherwise, you just have ipsy dixit, and I'm not really interested.
I don't understand how you're not understanding what measurement is. That's what it almost sounds like you're.
I know
implying.
very well. I know very well what the measurement is. I'm just not silly enough to.
How many
talk about
inches are in a mile?
How many inches are in a mile? I don't know that off.
Yeah,
the top
that's
of my
like no one would know the answer off the top of their head. So basically, I'm saying Google it. How many inches are in a mile?
God, do you really want me to Google it? Okay, fine.
Yeah, I'm for the sake of the conversation. Yeah.
Okay, inches in a mile. Let's look.
What is the contention?
360.
Is it decipher?
Yeah, this is getting weird.
It's my contention is that he's trying to say that measuring distance traveled is dependent on the Earth being a globe,
Correct.
and it's not.
It is correct. You have no basis for that statement. It's just Bree's shop of ipsy dixit. That's
No,
all
it's
you got.
not. Okay, how many inches are in a ruler? Like a basic
How many
ruler.
inches are in a ruler?
Yeah, seriously.
Is that where you're going with this argument? I don't see how that's going
Well,
to
you
help.
seem to not understand that you can measure a mile with inches, and that is on a ruler. So you seem not to understand that. So that's why I'm getting
So
to the basis of it.
Go ahead and take your ruler and measure a mile for me, and then come back, and then I'll care about your argument. Otherwise, you're talking like a child. It's silly.
What does me having to personally go outside with a ruler and measure a mile have to do with the fact that I'm literally explaining how a mile is measured?
You don't
how it is
understand
measured.
anything about what you're talking about. You're making an assertion based on, again, this is the same problem Killian has. You've measured distance in a very small capacity in your day-to-day life, and you think that's how it works at scale. It's extremely naive. It's not how it works.
As gaslighting generalization arguments.
Yeah. Fallacy.
Bree just said how many inches are in a ruler, not realizing how dumb that question is. It just depends on the size of the ruler.
Yeah.
Is this contention
I
between
literally
whether you could,
specified a basic ruler. 12.
What kind of a
That's
basic
what
ruler?
you're
A metric or regular? Yardstick? Baby ruler? One
well,
for kids?
I don't think anyone's taught. All right. I mean, a 12-inch ruler is not really kind of that relevant in this. So, is the contention about being able to decipher? Is the contention about being able to decipher the shape of the surface based on just a point A to point B distance or multiple points? Is it one of those that you guys are the contention?
Talking about long distances along a straight line.
Long distances that I've provided evidence.
It doesn't hold any weight to the globe or flat. It doesn't. Because a standard ruler, which is what I said earlier, a basic ruler is 12 inches, and you can literally measure that.
Is that what you got?
What?
Is Bree's shop of Ipse Dixit? You just serve.
You got to stop over talking. That's all. I don't know what that even means, but that's just not. You're just like ridiculing. That's not really the topic.
Not ridiculing. I'm
You can't
saying
handle
that.
this ruler argument.
What is the thing you're saying? Ipsy Dixie? What is that?
It means because I say so. There's no substance to the argument. It's just a blind faith assertion to support your paracosm. That's all you have.
It's a blind assertion that
Yes.
there are inches in a mile, and you can measure that.
With a ruler, you're delusional if you think that people do that.
The
Go out
whole
and try it
point
and
is
come back
that
to me.
the whole point, which I guess you're missing. The whole point is that you can measure a mile regardless of it being a globe or it being flat. You can
But
measure because you're
over a
literally just
long
measuring the
distance-
inches. What?
How would you do that? How would
Is
you do
anybody
that?
contesting that though? I thought that this argument was going to be it was more about whether multiple points can decipher. Like if you have not only point A to point B, but you have a point A to point C, point C to point D, or you make a triangle. That's not what's being discussed. You guys are just talking about.
I don't know how we got
just a point A to point B, just one measurement. That's what you guys are
I
discussing?
don't know how we got to this ruler thing, but go out and measure me a mile with the ruler and then get back to me if you think this argument makes sense, because I think it needs more time in the oven. Like I have evidence, and I'm telling you that whether it's whatever metric of distance, you could use your odometer in your car. Go drive 500 miles. You can measure that distance linearly with an odometer. Any sort of map that you use at that distance, the only way to accurately measure that distance is with a spherical geometry using the Haversine formula and the distance between A to B. That's a fact.
So whoever was asking that question, he just answered you, by the way. He just repeated what he's been saying. So if you're curious as if he's talking about like, flight paths going from one place to another and it takes way longer or shorter than if it's on a flat or globe, that's not, he literally just repeated that it doesn't matter if you're driving 500 miles or how many miles you're driving. The calculations for it are dependent on it being a globe. For it to be accurate. That's what he's saying.
The amount of linear distance, has to be assuming that you're on something with no topography at all.
No, it's not.
Because what she was saying about measuring a mile out with a ruler, like
you think that's a good argument, Stacks? Come on.
You'd eat up 5,280 rulers, right?
Yeah, but
like
my point is nobody's out there doing that.
Anywhere near you, right? You would probably eat up those rulers before you measured the mile, like topographic, like over top.
Look,
because that's a point-to-point relationship. That's
if your argument for flat Earth is go out and measure a mile with the ruler,
distance of road is going to be longer because of topography.
Okay,
you get that? Like,
yeah, but topography is
can
different.
You stick that in your Haversine craw for a second and just like entertain the?
Sure.
She was just like, I think just bringing.
Okay, but now let's take a drone.
I think there was even more to that she was going to get to, but like we won't.
I don't think there was anything more to that. I think
you don't
that.
Think so?
I think that's an argument that needs more time in the oven. If you're saying pull out a ruler, I think that you're not really contributing.
You're completely strawmanning the argument. I asked you how many inches. What?
You don't have an argument. You're just talking about inches in a mile. It's ridiculous.
You didn't even.
Yeah, because you're. Oh my gosh.
just allow her to speak. It would be really cool. Like without
Okay,
you
fair
trying to declare what she's already trying to like argue.
Go ahead.
I just okay. I should ask a question, right? So the question I'm going to ask you is why do you think I pointed out that you can measure a mile by something such as yardsticks or inches? Why would you think I would bring that up?
Because I think you're trying to say that it's independent of the shape of the Earth what the distance is, which is incorrect. And I gave you specific evidence, which you haven't rebutted in any way. What evidence, what argument do you have against the fact that there's only one correct way of measuring the fuel burn between 2 points in an aircraft? And that is a great circle distance calculated with the Haverside formula, which is spherical. And if you were to pull the Schuller oscillations from the inertial navigation system to measure the angular torque rate of the adjustment to the vertical over that distance, you would get the precise rate of curvature that matches the globe. And if you did an optical measurement, you would also get that same value. So we have multiple converging lines of evidence that it's a globe. That's just how it is. And then, oh yeah, you can go with your own GPS, pull the raw ECF coordinates, and you can get the curvature that way.
Have you finished?
Yeah.
Okay, I didn't want to talk over you. So again, the whole point I'm making is that it's independent of it being flat or a globe, because it's literally just a measurement of how far you traveled. Someone even mentioned topography. That's pretty much speaking for itself. If you're driving through a terrain with a bunch of windy roads, it doesn't matter if you're going a windy road or if you're going in a straight line. A mile is a mile is a mile. It doesn't matter. Like, that's the whole point I'm trying to make.
You're just saying that. You have no argument. Counter my argument. I've shown you that that you cannot measure a flat Earth distance between point A and point B and calculate your fuel accurately. But do you think they're just like winging it on flights?
No, you keep straw manning as if I'm talking about any of the flight related
counter my argument
formulas you're bringing up. Because you have already repeated for someone else who already asked this question what your argument was, and at least part of your argument. Let me rephrase that. Part of your argument is that any distance has to be dependent on the globe for it to be calculated correctly. Yeah. Which is not true, because you can, which would be tedious to do. I agree with you. For someone to do this would have to be really trying to just really try to prove a point that should be common sense. And it's that you measure miles by measuring it with inches, meters. It doesn't matter how you want to measure it. It doesn't matter if it's on a square, if it's on a triangle, if it's on a globe, if it's on it doesn't matter what shape it's on. A mile is a mile. And it's measured.
So when I take off in my airplane, I just won't worry about the distance between point A and point B and the geometry.
How does that relate to what I just said?
Winds? It should be pretty obvious.
Well, then explain how it's obvious how that relates to what I said.
Because if the distance doesn't matter, and it's just one way is the same as the other, then it wouldn't matter whether I used a flat formula or a spherical formula to figure out how much fuel to bring. Would it?
When did I ever make the statement that you should just disregard the distance and it doesn't matter?
Well, I'm asking you as a clarifying question. Can I use any distance formula? Now I want to take off in my airplane. I'm a private pilot. I need to figure out how much fuel to bring. How do I figure out how much fuel to bring to go from point A to point B? How do I know that distance?
You probably traveled it before.
Have you finished that? Huh? Go ahead.
And then how did I map that distance if I traveled it before? The Haversine formula and a great circle distance between points A and B.
Why did you have to switch to planes? We were talking about cars and things.
It doesn't, well, because the nice thing about planes.
You know what? Like, you used to be a lot better at arguing things and a lot more honest and a lot more polite when you were here before you started your own like little server thing. You know.
Okay.
And
He's
that
picked
goes the
all
same
the key
with every
documents.
other person that does the same thing. Every other Glober that goes and starts their, they get worse at their arguments. You
Yeah,
get
he's
in
got
your-
so
you
shit,
get
hasn't
in
he?
your- He used to
Yeah.
be better. You used to be better. I want to tell you that.
Thanks for your feedback.
Can we grill this like airplane thing? I just want to work
So
it.
the
work
reason I
this
bring
out.
up airplanes is because airplanes
Yeah.
fly in a level path that is independent of topography. That's why I bring
Okay,
it up.
are they they're flying in a fluid, right?
Yes, they are.
Cool. A dynamic fluid, right?
Yes, they are.
Cool. So you got winds coming at you, winds like prevailing
Yep.
winds
Yep.
behind you, lateral, all the rest of it.
Yep.
Right? Does that affect the amount of fuel that is required?
Of course it does. But
so then,
how about this?
Okay.
If I fly that flight 100 times, there's going to be variations due to the wind, correct? That's variance.
Sure.
Then there's going to be a
Then you do-
systematic component. Then there's going to be a systematic component, and that is the distance. So you
Wouldn't you
haven't
just,
solved
like-
the problem for yourself. You haven't solved the
Okay.
problem for yourself by introducing a random variation, because the end of
Okay,
the day is going to be a random variation around a fixed distance. The fixed distance can only be measured in one way.
Okay, you just invoked that there were multiple trips being taken. Why wouldn't they just average out the amount of fuel that they used, rather than this like topsy-turvy mathematics that you're applying? Why wouldn't they just like average out the fuel?
In that case, you would run into more issues with the winds and stuff like that. But they actually do predict the winds along the path. We are at the point, and in the past, we had, we no doubt had issues with logistics and planning and things like that. When we started off in aviation, planes got lost all the fucking time. Now they don't.
We're not
It's
talking about lost
exceptionally
planes. We're
rare they're
talking about
playing-
quantity of fuel.
Yeah, but the whole point
We
is
don't
that
need a history
all-
lesson in aviation.
Yeah, I mean, it
Cool.
would be helpful, honestly. But between the 2 points, we want to calculate a precise amount of fuel based on the distance, and then we want to add in the effects of wind, and then we want to bring a margin of error that we have estimated over time.
Yeah, you've estimated the amount of fuel that you've required to take. Why do you need to calculate the measurement and the distance if you've got all these data points that you're referring to? You just wouldn't do that. You just go by the amount of fuel.
Oh, that's
And
not how
also,
it works. That's
like,
not how it works. Just
isn't it-
again, what is your basis for that statement? Are you a flight planner?
the basis.
Are
No,
you a flight
are
planner?
you? Are
No,
you?
but I can point you. I can pull up global navigation for pilots. I have a copy of it, and I can walk you through how flight planning works. And what you're saying is
Great,
incorrect.
man. Cool.
Yeah, but dude,
No,
we
they-
all have
like-
we all have the internet. We all
So
have
again-
the internet.
So again, it's another.
You just
it's a-
tried to pull a credentials fallacy.
Okay.
There's no
Yeah, so
credential
you-
fallacy. Oh no, come on.
You just
Come on,
asked
Yeah,
for
you're invoking this, and their claim that they're using this mathematical equation doesn't actually mean they're actually applying it, right? You're saying
That's
that they
a very
can
weak
calculate the
argument.
fuel like
A
that,
weak argument.
whether or not they
So you-
actually do that. Pardon?
That's always what you guys say. You get direct evidence. It's like, okay, here's a manual of an inertial navigation system showing they account for curvature. No, they don't really do that. It just says so in the manual. Oh, here's global navigation for pilots, describing
Okay.
how you calculate fuel burn using the Haversine formula. No, they don't really do that. They just kind of like figure it out over time. And
Okay, can you can we just jump through a couple of quick hoops? Can we just jump through a couple of quick hoops, right? What
yeah,
like
sure, I'll do hoops for you because I respect
the
you.
linear distance that would be on a flat Earth, right, versus the distance traveled on a globe. Do you want to pick a distance or something, and then tell me about the amount of fuel load that would be required exponentially higher, and then we'll do a comparison with their safety or their measure of like safety.
Oh yeah, that's a
So,
great question.
Like, can we pick
how about
like
Sydney to Perth, or not Sydney to Perth? Perth to
Reasonable.
Santiago. Perth to Santiago. That's a great one.
Okay. No, it's a very controversial one.
Oh,
too much attention.
now
on
you
it.
don't want to talk about it.
Yeah, because you know the
you messed up,
consequences of that
Ricky.
particular flight, right?
You got yourself
No, no,
into
no,
a
no.
little bit of a hole here, buddy. You brought it up.
No, I haven't. No,
Yes,
yeah,
you
I asked
have.
us to pick one, right? Yeah,
Yes,
and I
you
said
have.
anyone, and you picked the one that's like the most controversial for a reason, right?
Oh, because you don't
Pick
want to
one
talk
that's not
about it.
controversial. No,
Sure, I
no,
could
just
pick.
pick
I
one
could,
that
no,
has.
no. Let's pick this one. Why don't you want to talk about it?
Yeah, can
Sydney
we
to
pick another one?
Santiago. Why don't you want to talk about it?
Yeah,
No.
I'm
I think we're going
vetoing
to talk
that
about
one
this
because
one.
of
You
its.
brought it up. You brought it up.
Yeah.
You don't have a reasonable,
Okay.
good faith objection to this flight.
Jesus Christ.
So let's talk about this one.
Okay, if you're saying that you can talk about any flight and you're being so persistent on this particular flight, and I'm erring on the side of caution and saying, hey, that's a controversial flight, you recognize how controversial
What does a
it is,
controversial
right?
flight mean? What on earth does that mean? When people get on this flight, are they like, "Oh my god, I'm getting on the flight from Santiago to I'm getting on the flight from Santiago to Sydney. It's so fucking
Dude, he's asking
controversial."
for one that happens every day. That one doesn't happen every day.
Yeah,
Well, why
dude,
is
and I
that a
actually looked up
requirement?
that flight.
Why
I
is
looked
that a
up that
requirement?
flight, right? But no, it's not a requirement, dude. I'm just looking for like,
Well,
let's just pick
you're
an
making it
average
sound
flight.
like it was a
You're picking the most exceptional flight that only came on board, like what, in the last 5 years or so?
In the last
let's
5
just pick
years?
like
Do you have any
Yeah.
evidence for that?
I mean, when's the first time that they ever actually run that flight commercially?
Well, you seem very sure. You said 5 years.
I said,
That's an affirmative
yeah,
claim.
I said around what, 5 years or so. That's what I said.
Okay, well, we have
Yeah.
to pull the flight data. I'm not sure that that's the case, but even regardless, doesn't really matter. You should be able to, for any flight on the Earth, there should be no issue.
Exactly.
There should
So
be
pick
no
another
issue
flight.
for you.
That's what I'm asking
Okay,
you
cool.
to do.
So
Pick another flight.
how about the one that went over Antarctica? You want to talk about that one? I have
You
the
really
flight
want to
data
go for
it.
like the most? I want the average flight. I just want a flight from bloody Dubai to LA or something. Like that one would be
Dubai
better.
to LA. Let's look it up.
Okay. And so your Habasine, is it Habasine? Is that the pronunciation?
Let's see.
This
So
calculation will tell you how much
go to
fuel.
Mackay Vector.
Qantas.
And then let's go ahead.
2012.
Let's set up a flight plan. Gosh, I don't know. Okay.
Okay, so what I'm trying to okay, because I don't want to get too stuck into the minutia before we do zoom out for a second, look at the big picture of what I'm trying to get to, right? I want to know what the distance is over the supposed flat Earth, and then the globe exact measurement that it's proposing. Then we need to look at the fuel mileage, and then whatever they're calculating in as a safety margin of error, and then compare the two distances and say, well, would the safety margin of error account for this supposed sort of curvature of Earth? Because if it absorbs, if the point at which the
it does.
the fuel requirement for the flat Earth plus
pull it up
plus
for
the
you.
safety measure then equals somewhere around the sort of the global the globe measurement from what was it, LA to Dubai.
Okay,
that
so,
sort of
so
accounts
you're
for that and-
okay. Let's get specific then. So I'm going to pull up. So I have the very first chapter, or one of the simplest chapters. Let me pull it up for you. In Global Navigation for Pilots, and we're going to talk through all of the spherical geometry that's involved in calculating distances.
No, we're not. We're gonna cut to the chase here. We just
so
look
what do
up
you
the
want here?
distance. We look up the distance, the claimed amount of fuel that's put in there, the claimed distance of the flat Earth, and then the supposed margin of error that they would apply. And we will just look at those three figures and see how they all compare. You want to get stuck into all this weird minutia stuff, dude.
Well, now you're getting into a bit of minutia, but so
it's like a direct
measurements
comparison.
do you have? What measures? So again, so you should automatically run into some issues here, because
So if we took the distance
there's
and then we looked at the 8 inches,
there's no existing flat Earth measurement of these flights, is there?
What does that even mean? I'm
doesn't-
honestly
yeah.
failing to understand what is going into distance here. What factors are going into how distance is calculated here.
The Haberstein formula. That is the only way to correctly calculate distances on our Earth.
Is that between two a latitude and longitude points?
Mhm.
Yeah, okay. So are you saying that is there a map that the latitude and longitude points aren't in the correct places? Is that what you're saying?
Sure, of course there are.
Oh, really? So which map is that?
The dumbass one that Killian just posted.
Which I didn't see that. Can you explain it?
It's some stupid moon map thing.
Oh,
Total fantasy.
is the latitude
So there's
and
one right there.
longitude lines on it,
Dude,
sir?
Huh?
Is there latitude
you're
and longitude
filibustering.
lines on it?
I don't see any graticules on there, so
You don't see any latitude or longitude lines?
no, I don't see any gratis on there.
Okay, so what was my question to you again, sir?
If there's a map where the latitude and longitude are in the incorrect positions.
Yes, so that map would be the one.
Do you
correct?
think that all maps? Do you think that all maps have correct distances just on the basis of latitude and longitude being on the map?
Well,
Do you know
typically,
do you know what a graticule is? Do you know what a grati is? Are you part of the grati gang?
no, I don't know what a graticule is, to be
Well, then
honest
you
with
don't
you.
have any business talking about cartography if you don't know what a graticule is.
Well,
Jeez.
I can look it up real quick, but my question was on
Yeah, you
if
don't
there,
have anything intelligent to add on cartography if you don't know the basics of how latitude and longitude create a graticule.
dude, why you gotta be so gay, bro? Latitude and
I'm gay as
longitude.
fuck. I'm gay as fuck, bro. You guys already know that.
No, I get it, but latitude and longitude positions, like on any map, that the distance between those has been taken off of the sky.
Okay, you gotta brush up. So I see that you have been following Chain a little bit. What is
No,
your basis for that statement?
okay, is there a
Papa
point
Shane.
on
I
the
know
ground that
Papa
states
Shane when
this
I
is
hear
a
it. Buddy.
latitude and longitude position, or is it a point that's depicted from a GP of a star?
Can you say that again?
Is there a point on the ground that's depicted as a latitude longitude point, or is it a point that's taken off the sky with like a GP of a star?
It's not required to use the GP of a star to have latitude and longitude. There's other ways of
Okay.
calculating it.
Okay, very good. So if I wanted to calculate latitude and longitude and we're not going to use the sky, are you going to pull out your pendulum?
No, I would use the raw ECEF coordinates of GPS and map it that way.
Okay, and what is that? How'd they get that?
How did they get that?
Yeah,
Do you want me to
the
explain to you how
Earth-centered,
GPS works?
Earth-fixed coordinate system.
It's literally just the positional data. And then I can figure out
Position of what?
Position of the receiver.
So the
And then I
position
can
of
use
the
that.
receiver.
I can use that to calculate latitude and longitude. But it's not dependent on latitude and longitude. You know how
Okay, but
ECEF coordinates work, right?
yeah, but I understand what you're saying, but the latitude and
Do you?
longitude position isn't it's a position on Earth that we've determined this position correlates to this position with the celestial sphere, correct?
So are you telling me that you now accept that the sky tells us about the shape of the Earth?
Oh my God.
Dude, are you not listening?
No,
Like,
I am
what are you
listening.
doing right now?
I am listening.
Why
I'm
are
just
you being a
curious.
sophist? Why don't you just answer the questions honestly?
I am answering the questions honestly.
Okay. Is the latitude and longitude positions on Earth based off of us, like the positions in the sky? Yes or no?
I just told you a method that we can use to determine latitude and longitude without reference to the celestials.
Dude, who was the first person to put latitude lines on a map?
Good question.
You want to tell me?
Oh, you have no business talking about this if you don't know that. La, la, la.
Well, I mean, you're the one that's trying to like school me on like latitude and
No, I'm
longitude.
just asking you. I don't know
graticule.
either. I don't know. From what my research, it says the Phoenicians, dude.
The Phoenicians came up with latitude and longitude?
With latitude lines. Yeah, the Phoenicians, dude. Go ahead and
Really?
Google it, bro.
Okay, let's check it out.
And who calculated latitude lines below the equator, sir?
Well, that would have been much later on, right?
Yeah, interesting, right? So the first latitude lines are based off of what? Angle measurements to Polaris?
Oh God, don't start with that Nathan Oakley crap. Don't start with that Nathan Oakley crap. You're better
No,
than that.
I'm
Tula.
asking a question. I'm not
No,
going in
you're
the Nathan
not.
Oakley direction because my
Yes,
question
you
is
are. Don't
if we
play
get
with
angle
me,
measurements
sir.
sir,
Don't
listen,
play.
listen,
Don't play.
listen.
I
I'm
know the
not doing
script,
straight
bro.
lines. I'm not giving that argument.
Stick with Papa Shane. I like Papa
Can you
Shane.
just
I
relax?
don't like
Can you
Nathan
just
Oakley
relax
crap.
for a minute?
I'm super
Okay.
relaxed. I know a script
You're
when I hear it,
funny
brother.
muting me, dude. When I'm in the middle of talking and you're talking over me, you sound very nervous. So when we take an angle measurement to Polaris, all of a sudden we get all our latitude lines in the north. Now, when we go to the south, in order to get the latitude lines, we're not going to be able to take measurements to Polaris here anymore. So is this just calculated out based upon what the north did?
Why can't we just use angles to Polaris the whole time?
Excuse me?
Why can't we just use angles to Polaris the whole time?
I don't believe Polaris is visible from every place upon the earth. Is it?
Why not?
No, he's trying to say that it should be visible on a flat Earth. He's asking me
Oh.
why can't you see Polaris?
Oh, I understand what you're saying. Well, I'm not exactly sure, but that's not the point. The observation
a
is
very important
we don't see Polaris from every place upon the earth. So if we derived our latitude based upon seeing Polaris, when we can't see Polaris anymore, how are we deriving our latitude? Is it a calculation or is it an actual measurement?
Well, now you're going to get into calculations versus measurements. But you've introduced something you shouldn't have introduced, which is the inability to
please don't tell
continually
me what I
measure.
can and can't do, sir, because it's interesting to me that it seems a lot of things are calculated out. Like, okay, for example, we have the pendulum, right? It precesses in the north at this point at this certain rate, and then it precesses a little less as we get towards the equator. And then it's calculated and assumed that it won't precess at the equator. And then it's calculated and assumed to what it will do in all these other places without the actual observation. So that's what I'm asking for. Do we have the actual observation of how did we determine the latitude lines in the south? Is it based off an actual observation, or is it just a calculation out from the north?
I don't know the answer to that question off the top of my head.
Okay, no problem. No, I was just wondering myself as well. That's all, dude. I'm really not trying to like argue with you, bro.
All right, fair enough. Yeah, fair enough. So,
and what was that word you asked me to look up before? Gradical?
Gradical. Yeah.
Oh yeah, and to Ricksky's point, the Qantas flight or whatever, the Cindy to Santiago, it started in 2012. It is fairly new.
Okay, thank you. Meridian
I wasn't a
altitude
flat
method.
earther at the time, but I've taken some kind of flight from there. I was in Peru. I had to get back to Australia, and then we missed our flight as well. And I think I went around Africa or something, because I can remember all these in Africa that they've got farms and they make them like circles. And there was like all this land like that, like with just squares with circles. But I on my passport too, like you can't tell exactly like what flight path I took, and I don't know if I could ever find out. But yeah.
Well, if you know the flight, you can look up the track.
Yeah.